Hello everyone, welcome back to JDCodebase. This is the DSA Foundations Series. Today we are starting something very important in the data structure, that is the arrays. If you understand arrays properly, 40 to 50% of beginner DSA becomes easier automatically. Today we will understand what is an array, how indexing work, why indexing is the big of one, and what is traversal, why insert and delete are costly, and we will also solve three small practice problem. Don't worry if you are new, completely new in this topic. I will explain everything from zero. So first question is, what is an array? An array is a linear data structure. Linear means elements are arranged one after the another. It stores multiple values in a single variable, and very important, these elements are stored in a contiguous memory location. Contiguous means side by side in memory in a single row. Now let's not just talk about theory. Let's see in the VS Code in the JavaScript. So I'm using the JavaScript programming language for this DSA Foundation series. So let's start by writing. First, let's make an array. Let arr 10, 20, 30, 40. So here I created an array with the four numbers, and this single variable arr is storing multiple values. So let's run this. First I have to console this arr and node array. Okay, node array basics, and yes, I get the 10, 20, 30 and 40 this array. So in JavaScript we do not see memory directly, but internally these values are stored next to each other. Now let's understand indexing. Index means the position. Important rule here is the index always start from the 0. So at index 0, so 10 is at index 0, 20 is at index 1, 30 is at index 2, and 40 is at index 3. So let's console this. Console.log arr 0, console.log arr let's say 2, and let's run this. I get 10 and 30 as expected. So when I write arr 0, I am asking give me the element at position 0. When I write arr 2, I am asking give me the element at position 2. So this is called direct access. And here the time complexity of accessing an element in an array is an big of 1. Why big of 1 means constant time? Because no matter if array has 4 elements or 4 million elements, accessing by indexing index always take the same time, because computer calculate memory address directly using the formula. That formula is the address is the base plus index multiply size. You do not need to memorize this formula. Just remember, indexing is always fast as compared to the other operation. Now let's move to the traversal. Suggest we want to print all the elements for this array. Now we cannot manually write arr 0, 1, 2, 3, f2, so on. So we use the traversal. Traversal means visiting each element one by one. So let's write a for loop. For that we use the for loop. Let I equal to 0, I smaller than array dot length I plus plus, and console.log array of I. So here I start from the 0 and it goes until the array dot length and -1. Array dot length, that is -1. So and each iteration we print arr of I, means arr of 0, then 1, then 2, then 3 automatically. So we are visiting every element one by one. Now let's run this. I get 10, 20, 30 and 40. Perfect as expected. So now time complexity for this is big of n, because if array has n element, this loop run n times. So that's why time complexity is the big of n, and space complexity is the big of 1, because we are not using any extra array or object, just a single variable I. Now let's talk about the inserting element. For insertion, we have two cases. First one is the insert at the end position, means at the end of this array, or insert at any position in between this array. So let's see here, array dot push 50. So this element add to the array means or to the last at the end of the array. So this is big of 1, because in most cases, because no shifting is required. Let me write here console.log arr, and I get the array 10, 20, 30, 40, and 50 is added at the end of the array. So here this is big of 1 in most cases, and now let's see the second case, because this one is the normal one. There is nothing special in this, just a array dot push. Second one is the special case that says if I want to insert at index 2, means between this 0, 1, 2, means I want to insert at the at index 2 instead of 30. I want to insert something else. So to understand this, we will manually simulate shifting. So let's write here, let arr2, I'm writing a new array 10, 20, 30, 40, and give the index here. At index 2 I want to insert value, here is the, let's say 25. I want to insert 25 in this arr2 array at index 2. So for that, first I have to shift all the element, let I equal to arr2 dot length, and it runs till the this index, and I minus minus, and arr of 2 of I equal to arr of 2 I minus 1, and in last paste the element, means copy the element index at index this value. So here this loop start from the end, means ending index array dot length, and it runs here we shift all the element one position to the right, means array dot means last element we can access by I minus 1, basically means this is the array dot length minus 1. This is the normal way, and but we are copy this value into the arr of I, means actually value here I, and after making the space we place the new value at index 2, means all the values are shift. So let me show you here, console.log arr2. See, I get initial array is 10, 20, 30, and 40. After this for loop, I shift all the elements with these two elements at the one index after that, and now replace this value arr2 at index is equal to, let's see here, now I get 10, 20, 25, 30, and 40. So this is a big of an time complexity operation, because in worst case we shift almost all the element. If I say push the element at index 1, so in that case we have to shift all the elements. Now let's come to the delete operation. Delete is similar to the insertion, and delete from the end is easy. Just write arr2 dot pop, and just write here console.log arr2. Let's see. As expected, I get the last value here is the remove from this array, and so pop remove the last element, no shifting is required in this from the ending. So it's a big of one time complexity. Now let's come to the main part, delete at a specific index. For that, let me make a new array 3. Again the value is 10, 20, 30, and 40. A normal array, nothing special in this. and I want to delete at index let's say 1. And now first I have to start a for loop that I equal to delete index I is smaller than arr dot length minus 1 and I plus plus arr of 3, sorry, I have to write here arr of 3 I equal to arr of I plus 1. Means this time I have to copy the this I plus 1 value into the I, and also change the size of this array dot length equal to array 3 dot length, decrease the size means array dot length minus 1, and also here is the array of 3, not the single array. Now let's console this, console array of 3, console.log, right here. So let's see. So initial array 3 is it 10, 20, 30 and 40. I said delete the index at index 1. So here we shift all the element to the left side. So we override the deleted element. Means start from this at index 1 means 30 comes to 20, 40 comes to 30 position, and after that we change the size, then reduce the array length also. So this is the again big of n time complexity for this because shifting is required in this. Now we cover the traversal, insertion operation, insert at index, insert at end, and delete operation, delete from and delete from index. Now why array is a contiguous memory? So arrays are stored in a contiguous memory because of that indexing is very fast, but insertion and deletion in the middles are slow. Like here we can insert element at index means in the last is the easy, but removal from at any index is the difficult. So array are good when you need fast access, but you do not modify the structure too much. Now let's see the practice problem. Insert at index. I already show you this problem. So these are some array practice. So insert at index, this is a function. We get an array, index value and the value what I want to insert. So let's run this. So first again I have to write for let I equal to array dot length and I is small greater than index and I minus minus every time, and arr of I equal to arr of I minus 1, and also put the value at index equal to this value and return the arr. So a normal this value insert at index means here I am just writing the hard coded. Here I use the function by using the function. Now just write array. This is a practice. So I get the 10, 20, 25, 30 and 40. 10, 20, and at index 2 I am inserting the 25. Same for the delete. You have to write it by yourself. And this is the special one, rotate right by 1. Means I have to means rotation means last elements become the first one. Means 4 is come at the first index. For that let me write here first comment this. So for that first take out the last element, array of array dot length minus 1. By this I am get the last element, that is the 4 in this case. Now start a for loop for let I equal to array dot length minus 1 from the last index, and array I is always greater than 0 and I minus minus. decrement each time. And now array of I equal to array of I minus 1, and means I'm shift the all the values from right side in this. Now let's override the value at index 0, this last value, and return the array. Now let's run this. Yes, I get 1, 2, 3, and 4 is come at the last index. So here we store the last element first, means take out the last element and shift all the values to the right side of the array. Then assign the first at the first index. So this is a big of n because we shift all the elements in this by using this for loop. So you have to write this delete at index function by yourself, and I already show you the rotate array by 1. So let's summarize. Today we learn indexing is big of 1 operation, traversal is big of n, insert and delete in the middle are the big of n, and arrays are fast for access but costly for the shifting. If you understand this clearly, many future problems becomes easier for you. So that is for today's video. Don't just watch this video, open your editor, write the code yourself and practice it. In the next video we will start solving real interview level problems based on the array. If this helped you understand array clearly, like the video, subscribe to JDCodebase. We are building DSA from the zero, step by step, no shortcuts. I will see you in the next video.